Good morning, good afternoon, and good evening, wherever you are. We appreciate you joining us here at CIQ for another webinar. This week, we're going to be talking about Peridot, the new Rocky build system, and I have Neil, Skip, and Mustafa here today to talk about this. So, Neil and Skip, we've seen you quite a few times. We know who you are, but I'll let you introduce yourselves quickly. Let's go to Mustafa. I don't remember if you've ever actually been on before. You probably have.
I don't think I've actually been on a webinar before.
He tries to avoid it as much as
Tries to
possible.
avoid it. Well, tell us about yourself, Mustafa. Who are you? What do you do here? What do you
Hi,
do for the
everyone.
Rocky community?
Can you hear me?
Yeah.
Okay, amazing.
Good, man.
So, hello, everyone. I am Mustafa, and I'm a software engineer at CIQ, and I'm also leading the release engineering team together with Louis Abel at the RESF.
Thank you. Skip, I'll go to you next. Tell us who you are again.
Hey, I am a engineer at large, kind of, sort of, here at CIQ. I do all kinds of random things, and I'm also on the Rocky Linux release engineering, dev, whatever you want to call us, team. Also do a lot of random things on there, mostly package builds, and and I have a lot of fun.
That's awesome. Neil, welcome back.
Hey, I'm Neil Hanlon. I am a potato engineer and administrator of pens and office supplies here at CIQ. I'm also one of the team leads for the infrastructure team for Rocky Linux, along with Taylor Goodwill.
Thank you very much. So let's go ahead and dive right into it, guys. Let's talk about Peridot. I think the first question that a lot of people have whenever I get involved and they start seeing this stuff is, what is Peridot?
So Peridot is a new cloud-native build system specifically targeted at RPM building. I don't know if you want history, but I can give like a
Absolutely.
backstory.
Yeah, let's have
So when
history.
we first started out, we did use the available tools, and we found out that it worked, but it was mostly targeted at if you're actually developing the OS itself. And it lacked a bit of separation that we wanted and how we want to manage the build system itself. So we wanted to create something that we could run on modern technology and easy for us to use and easy for us to manage. So then Peridot came along.
Yeah, I think one of the really important points there that Mustafa touched upon was we needed a separation and an ability to hand off the ability to build these packages and manage the deployments of the packages into repositories and et cetera, for the community to be able to take part in building Rocky Linux from the ground up, including patching things and in the future, trying to get rid of the problems that exist in any sort of open source organization where you're building things and only some people know how they build. There's a order in which they need to be built to produce the right outputs. And additionally, there's some secure bits that need to be kept secret so that the operating system itself stays secure, not only from a booting perspective, but from a software supply chain perspective as well. So we're hoping that Peridot will allow us to iterate on these sorts of security practices that the organization itself is built on to enable the community to produce what they need to with Peridot.
So go ahead,
I'm going
Skip.
to chime in too because we're all going to answer
I
this.
guess we'll let you talk.
I'm going to do mine stupid simple, like I like. Peridot imports RPM code and it builds RPMs, and that sounds simple, but it's actually there's tricks to it, right? It's a little more complicated than that, but that's what Peridot does in an organized way. We import code and we build.
So I guess that kind of answers the next question a little bit, but what is Peridot not?
I'm going to continue. Hang on, Mustafa. Hang on. Whoa there. Peridot, I would say a lot of people, because this is the number one thing whenever I talk to people about it, that they have asked me, Peridot is not a general purpose building system for throwing together any, pick a language, right? Like it's not a Python build system, or it's not a PHP or a C or a Go build system. It doesn't really. It's very much geared towards the production of RPMs and it's really why we, it was purpose built for in scope, basically for producing Rocky Linux RPMs.
Thank you, Skip. Mustafa, do you have something to add to what it's not?
No, I think Skip has explained it perfectly.
Sorry, Mustafa.
No.
I got you.
Typical Skip. So I know there are other build systems out there, and you kind of touched on it a little bit. I think all three of you actually did. But tell me more about why Rocky Linux uses Peridot instead of something like Koji. Neil, I'll start with you.
Sure.
I'm just going to pick on you.
There's a lot of history in the tools like Koji and its related family of distribution forges, I guess is the best term to use there, that take RPMs or take sources, import them, build them, and release them somewhere. And back when these sorts of tools are being developed, there were decisions that were made that were available with the technologies at the time, and some of those are not how we wanted to deploy and scale the infrastructure that was building and deploying Rocky Linux. And one of those big ones for me from an infrastructure perspective is our hard requirement on NFS as a backing store for all of the packages. So in Koji, you have to store every single package, and the result of all of those package builds on a single I guess it doesn't have to be a single, but on a single NFS file share that needs to be available on every single builder. So you can imagine that when you start getting out to wanting to scale across multiple regions and also have multiple architectures that are running these builds in disparate locations that may have increased latency or other issues, you run into infrastructural challenges with having the data available where it needs to be across continents and synchronizing that atomically in a way that allows builds to be performative. And what we've been able to change with Peridot is eliminating a single file store altogether by leveraging an object store as the back end, which can scale very easily horizontally and allows us to replicate that data and become multi-regional, multi-zonal in a very easy manner. Combined with some other tools that I'm sure Mustafa wants to talk about, like Yum Repo FS, which is a microservice part of Peridot, that allows us to serve repositories for builds, specifically like when we're talking about Peridot and Yum Repo FS, where they it's a snake eating its own tail, where it feeds itself the packages from itself, and that's how we can bootstrap the packages. But those tools allow us to do highly scalable builds up to, I think, 2,000 or 3,000 packages we've found with our current infrastructure in parallel building at a time on multiple architectures.
That's fantastic. I'm sure, Mustafa, you have things you want to say, so I'm going to let you go.
So Koji is, again, an amazing system that we have relied on for a long time when we first started out building Rocky Linux. The problem that may occur is that it doesn't really manage the whole process. It does still leave a lot of room for the caller and user to take some action. Peridot, on the other hand, has a separation in projects, and each project has a catalog. So Peridot supports both a source type packages, so it's a package that you yourself manage, you yourself build, but it also supports pulling in RPMs or sources from a separate project, separate target. And that enables us to define beforehand, before we start building, these packages, this we want to import, this is something we want to build. And it also manages the importing process. And what it does is we have a set structure. It's both the source and the target follows the same structure. And a developer can't just go in and just build random, pushes, commits, anything from the source. We follow the same import process within Peridot. And once we click import, Peridot does imports and can apply patches that we declare beforehand. It's all traceable within Git, and then push that to our Git forge. And from that, it pins the hash. So if something changes, if the hash has disappeared, then you can't really build something else. You need to re-import and reapply the patches. It follows a traceable route of content and sources that we build. And once we reach that point and we start building the RPMs, it also stores them and manages them and manages the versions internally. So it's not really visible in the UI right now. But internally, Peridot actually manages versions, and you can look at history of versions, and we can also manage how we publish them. So we kind of combined multiple tools into one, made it easy to use, and we have a simple system of authorization. And also, we haven't really talked about it yet, but modules is also something Peridot supports, and it has combined into the same system. While with the old infrastructure, we would have to use multiple tools to kind of build these special types of package groups.
So let's kind of get into that a little bit before you say anything, Skip. I just want to ask another question. We've talked about project a couple of times. So what exactly, in scope of Peridot, what is a project?
So a project is basically a distribution, a catalog of packages, a organization of repositories that Peridot manages for you. So when we're building Rocky Linux 9, we have a Peridot project, and that turns into the distribution. And when we want to build a SIG, for example, then that itself is a separate distribution that we can add onto the core. So it's a group of packages and a group of, how should I say this, like an organization of repositories that Peridot manages for you.
Great, thank you. Skip, now that you're drinking, I'm going to call on you. You had something like that.
I got my tea. I'm ready for anything. Yeah, what Mustafa said was absolutely clear. It goes back to Peridot being tailored. It's very useful in general, but specifically for Rocky Linux's needs, where he mentioned you can have your own packages or you can import automatically from another source. And obviously, that's a huge interest to Rocky Linux, which imports the Red Hat Enterprise Linux sources and then builds them in an automatic way, because we don't want, Skip, for example, fat fingering Git, commands to import Red Hat sources and screwing up versions and whatever, because I'll do it, quite frankly. It's much cleaner to have it done in an automatic fashion, where either an automatic API call or a click a button and the latest, Apache from Red Hat Enterprise Linux is imported and ready to build, right? And so that's the traceability and I want to say the automation and the cleanness of it is super important to us as a project. Saves us a lot of time.
Thank you, Skip. So this is probably a question back to Mustafa, since he brought up modules. Can you give us a little bit more of an example of a module? Like, how does that work? And can you give me an example so that I can understand a little bit better?
Yeah, of course. So modules are a group of packages that usually depend closely on each other, and they specifically request that they are built together and are released together as a group. So, and they can also declare like order and basically our packages are very like related to each other. So when we're rebuilding a module, if something changes, then most of the time, or usually, we have to rebuild a lot of other components as well. So modules can declare that, for example, if this package is built first, should be built first, and then the next set of packages should depend on this package. So if the base package changes, then we don't really have to go and find other packages that are so closely connected to it and rebuild it. It's just like declared and it's released together. And on the user side, users can enable modules and use these package groups, and also utilize the feature of separate versions of the modules. So both like a group of packages that's getting built and also separate versions, multiple versions existing at the same time within the same distribution.
That's great. Thank you, Mustafa. So I think we have some stuff popping in. Before we get to Tron's statement question ask, I do see another one from Sylvie that says, what language is Peridot? Yeah, what language is Peridot written in? And what is it used for data storage?
All components are written in Go. The UI is in TypeScript. We use PostgreSQL for our database, and we use S3 or any kind of object storage for storing the RPMs itself.
Okay, thank you, Zoe.
Yeah,
Neil?
there's a couple of pieces around Peridot at the moment that utilize Python to do some conversions of the catalog options for us to do imports and builds. And on the opposite side, when we export back to the mirror infrastructure that runs and delivers the mirror list information to users of Rocky Linux, there is some Python used on that side and a toolkit to help with generation and downloading of all of the repositories that are needed for the distribution itself.
So Neil, you talked a little bit earlier about scalability, and this thing it's kind of a Kubernetes platform, right? So obviously that implies containerization. So how is that different than the other? I mean, you mentioned that like Koji has to use an NFS file system and has to have everything everywhere all the time. How does the containerization part of this make this scalable, and how does that work?
Sure. So we've chosen to implement this on top of Kubernetes for a number of reasons, but one of those is mostly the separation of concerns and security practices that are very well ingrained into Kubernetes as a structure for running your applications on top of, and looking at how kind of the best case scenarios or best uses of these technologies are done, and trying to adopt those best practices into how to build these RPMs. And at the end of the day, we're not doing really anything different than what Koji is doing. In fact, Koji and Mock, as a result, where we use Mock inside of Peridot to run the builds and invoke RPM build, but we also are doing it in a way that doesn't require having all of those packages everywhere all at once. We work. We automate the workflow in such a way that permits us to download and install the artifacts into these base containers for the architectures that need to build without actually having them on the systems themselves. So this not only allows us to build for multiple architectures. For example, we run in AWS as well as in various physical and virtual clusters in a couple of different areas for external architectures, but allows us to scale those out with auto-scaling groups for cost-saving reasons, as well as just only using what we need to use. And it allows us to build with extreme flexibility when we do have something like a module where you might need to rebuild one package because that got updated, but actually you need to rebuild all of Perl and in a specific order. So it allows us to take advantage of the cloud to do these updates very quickly and resolve any issues when they come up. In a much more reasonable manner.
Thank you. So I think Mustafa, you touched on this early. If you have a package that needs to be patched as it's getting built, so something's changed, you're going through the build process. I know Peridot can kind of do that. At what point does that happen? How does that happen? Is it during the import? It notices that there's something that's changed and has to be applied to it. What does that look like?
So we have an architecture called OpenPatch, where we also open source our patches. So we never do any manual patching. We always declare the patches beforehand, and we check them into our Git Forge. So before anything can be patched within Peridot, it actually has to be accepted into a patch repo within our Git Forge. It's all for like traceability purposes, so no one can just create a patch and build something in Peridot without it being like visible for the engineers.
Excellent, thank you. So plugins, obviously this thing is an open source tool, and we get that question asked quite often, like, well, what else can I do with this? Are there plugins for it? Can I write plugins for it? Can I plug into it?
So there are very minimal plugin support, but it has plugin support. We do plan to expand that, and there are probably a lot of options that a lot of things you can do. After building something, you can probably manage more of the compose or catalog process around it. But yeah, it's planned, but the current plugin support is very minimal.
Thank you.
One of the things
Go ahead.
I've been thinking about and kind of noodling on is how to hook into the different aspects of a build to be able to keep an eye on the status of a package as it comes through that process. As we look towards more automation, where if a package update comes in, it can be kind of imported and built into a staging area where we can then pull it from. And I think we'll get into this a little bit with look ahead and how we're going to be trying to track CentOS Stream, but the plugin functionality there and being able to hook in at different points within the process will allow us to, the possibilities, I guess, are kind of endless here, but a special interest group, for example, might want to have notifications if a package build fails or open a ticket when a package build fails. So those sorts of things are what we're looking to go and implement into Peridot so that it can be a true kind of central hub for all the building that happens inside Rocky Linux.
That's great. Thank you. We have a question from Tron. Does the concept of module streams bother Peridot, and can it support modules?
So no, it doesn't bother Peridot at all, and it supports modules just like a module build system, and it does that in like a more manageable way. So we kind of got away with some of the bootstrap steps of MBS and do that in like a more manageable and traceable way. So you can build modules, and you can even create your own modules without killing yourself so.
Yeah, that's kind of a great point. Where I had previously spoken about like a snake feeding its own head. That's exactly kind of what Peridot does with the module situation. Whereas with Koji, Koji is still used for building modules, and for example, our Rocky 8 distribution. But that's invoked by a separate process, this module build service, which helps Koji understand how to do the build ordering and the dependency mapping between all of these different packages that might exist in a module version. Peridot understands that natively, and so when it detects a package, it just goes ahead and fires off all the things it needs to do to update those packages when necessary or just build them for the first time.
Great. Thank you for the question, Tron. So one of the next questions, because this whole thing seems to have been moving incredibly fast, and there seems to be changes constantly and more features that are coming to this, but what are the future plans for Peridot?
So something that I've been working on personally is, sorry, I don't mean to steal you guys' thunder, but basically looking at the setup and the documentation around it. So Peridot is, in a word, I mentioned before, it's real simple. It just builds RPMs and imports stuff. As you've heard from, especially from these guys, a little bit from me, but especially these guys, it's hard, right? Like it's not as straightforward as all that, right? And because there's a lot of technical complications and so forth, and so there's a lot of clean documentation that's coming out that will be, kind of what we're going over here, really. Like, what is Peridot? What can it do? What can it not do? What kind, how do I access it? What do I, what exactly can I do with it? That sort of thing. And also how to's, how to do this. Like, how do I import packages? How do I create, a catalog for my project or whatever, that sort of thing. And so that's one of the things I'm excited about, because I'm big on documentation and reproducibility.
I'm glad somebody is. It's typically not a developer role for sure. Mustafa, I think you had something you wanted to say when it comes to the future of Peridot.
Yeah, so we definitely want to expand upon the plugins and being able to set up the SIG projects as the SIG leader wants to set it up, or the SIG groups wants to set it up, help them customize Peridot more to their liking. We also want to make more UI improvements to make more features available from the UI rather than the API. I'm using the API more, so some features are lacking from the UI, but also expose more of the features on the API as well. We also are planning some more, like making some of the builds more stable if you're building out of multiple sites. Sometimes we can have some trouble with multiple sites, and that's usually expected. Doing multi-cluster, multi-site builds and coordinating it all together is a difficult problem. but we made Rocky Linux 9 happen, and it's very complicated under the hood, but the deployment process, managing Peridot has actually been amazing, and it has helped us, get everything under one roof. So you don't even realize that you're actually invoking so many sites that connect back to it. And the sites doesn't even need to have access to the NFS file share. They don't really care to kind of, in the end, how we combine everything together and then generate the correct metadata. So the old problems where all hosts usually needed access to NFS and the latency and the problems that was bringing in, that's now completely gone. You can run builds from anywhere, multiple sites, thousands of hosts, without really caring about where the data itself is.
Oh, that's really cool.
We exchanged one set of problems for an entirely different set of problems. That's what being cloud native is all about. You get rid of your classical infrastructure problems and you just replace them with new infrastructure problems that you can hopefully solve, or at least manage in a different or better way. Kind of actually what Skip was saying about documentation, one of the things I'm looking forward to is writing up some use case examples and documentation blog type style things on how you as a user might want to run Peridot and use it to customize an RPM or rebuild something, or even just understand how Peridot works from a building perspective to rebuild a simple package like Bash. So those are things that I'm looking forward to on the documentation front. On the technology front, kind of like what Mustafa said, getting this UI into a place where we can make it accessible for a lot of people without a whole lot of training or usage instructions on how to get around and manage things in there will be really good.
Excellent. I think we had a question that just came in. Tron, thank you very much. So he's asking about Yum Repo FS. He heard it mentioned earlier in the Peridot conversation and wants to know what is it and why wasn't it called DNF Repo FS?
So Yum is the old name, and that just kind of stuck. And it's usually called Yum repos. So that was kind of like why it's named Yum Repo FS. But what Yum Repo FS is how we kind of replace NFS. It's a completely virtual Yum server. So when we push updates to Yum Repo FS, we don't need any packages on disk to recreate the same metadata. Yum Repo FS, after builds, we usually cache and create metadata beforehand, store it in the database or S3, and during Yum Repo FS update, where we can swap in packages and swap out packages at will, different versions or a build, Yum Repo FS updates the metadata entry or primary lists to swap out the necessary information without having to go through the whole process, of computing everything and creating a new repo, which is also a very time-consuming task on the Koji side. So we kind of get very fast repos without ever having to pull in all RPMs into disk. And as we said before, we store RPMs in S3, and we kind of use a small trick. So the DNF data, it references to an endpoint, but the endpoint just pre-signs a S3 URL and just forwards to that endpoint. So in theory, we always have the NVR data always once, but we can use it in multiple repos without having to ever duplicate the NVR. We have only like one RPM. So that means that you can create thousands of repos. The only thing you're kind of storing is the metadata, which is so small compared to copying around the RPM all the time.
Absolutely. Thank you. I also have to say that Yum Repo FS is way easier to say than
what Mustafa so yeah, you're right. Yum is, to my dying day, I will say, Yum is it rolls off the tongue so much easier. And yeah, basically, it's something that when I learned, I didn't write Peridot. I'm mostly a user, but when I learned how it worked, I was like, oh, you guys are tricky, because what you're doing when you access a Peridot repo to download it or to pull the RPMs or whatever you want from it, you're not actually. So normally when we access a Yum or a DNF repo, we hit XML files, right? And we download those XML files, and they have information about our packages and where they're stored and such. Peridot's super tricky because when you're hitting that XML file, it's not a real file. It's being generated for you on the fly, right? And because we generate it on the fly, it can be whatever we want it to be, right? We can add and remove RPMs from different repositories and kind of what I call slice and dice them as we want, right? There's no limit to how many times you can mix and match different repositories, and it's really and as Mustafa said, the RPMs, when you actually go to download an RPM, it's just a redirect to S3 to get you your RPM. And so it's very, like I said, it's kind of sneaky in a way. You're kind of taking I love hacks like this, like where you're taking the traditional, oh yeah, we have a Yum repo and it's got some files and here's the RPMs, and we've kind of turned it around and said, well, the file or the information you're downloading is actually just generated from the database, like right, as you're downloading it effectively. It's cached, but it's it's cached for speed. But yeah, and then the RPMs you get aren't actually on the disk either. They're just they're what's the redirect code in HTTP? 301 or 302 redirects effectively. So yeah, but I thought, like, when I heard about that, I was like, whoa, that's it's really cool.
That is really cool.
It's really the power of Peridot really is the core of it.
It's awesome.
So Zane, I have something else to add, if that's okay.
Absolutely.
Peridot is also, we have looked at different systems and how multiple distributions are doing it, but Peridot is, as I'm aware of, is the only build system that also maintains the production structure. So after every build, the catalog itself, it sorts into the same structure that you would see in production. So if you point at Peridot endpoints, you'll get the updates. It'll be unstable. You can get like broken packages, but it's the same structure with all the module metadata in there, like already, even from the development like endpoints. So this is also something really new, really cool. And using that, we actually repo sync of Peridot. Just closing it, keeping it in a closed loop, and signing everything is done on the Peridot side. Once it's exported out of Peridot, you can't really change anything. If you do, the signatures are broken, even the metadata signatures. So we kind of try to keep it in one place, so all operations are done within one system. So after it's like out of that system, you can't change it.
Very cool. Essentially, what we can do then is start attesting to what is in an operating system when we release it, and what's contained in all of those updates, providing a cryptographical signature essentially on top of them, in addition to the signatures we already have on the packages as well as the metadata.
So Mustafa, we talk about Rocky 9 quite often. Sorry, Skip, I didn't mean to cut you off, but I got to ask this question. We talk about Rocky 9 in Peridot a lot. What about Rocky 8 in Peridot? Is that going to happen?
Yes, it's planned. We are still evaluating like options and automating, keeping the same systems, making it easier for us. So there are plans. We're planning on migrating Rocky 8 to Peridot as well.
Very cool. Skip, I cut you off.
Oh, no, you're fine. I was just saying to expand on what Mustafa was mentioning about how when things are done in Peridot, because of the way this Yum repo FS works, we can have ready to go repositories. So if you're familiar with Rocky Linux, you know about base OS and AppStream, and you might even have heard of CRB, which is Code Ready Builder. These are all the repositories that you access to get your packages in Rocky Linux. Those are ready to go in Peridot. So what Mustafa's saying, hypothetically, if you really wanted to, I don't recommend it, but you could point your Rocky Linux install to Peridot's base OS and get packages like the instant they're created, for example. Like, again, there could be breakages. We don't, it's
don't do right? this.
Don't do it. I'm just saying, hypothetically, if you wanted to, it would be, yeah. So they're just...
Good, that's good.
No, I'd say they look exactly like the production repos.
Yeah, and I was going to say, along those same lines, allows us to do what we're calling Rocky look ahead, where we're looking ahead at what's coming down the pipe from stream by looking at all of those packages that are being built and building them in a separate project, which, along with what Mustafa's talked about, with being able to serve artifacts from multiple or from repositories and pull those down into one place. Once we build that package, it means that whenever we need that package as an artifact for another build, to fulfill a build dependency or fix a bug with a regression in a build dependency, which happens fairly frequently when we need to build point releases, we have those packages around already built. We don't have to go looking for them. We're trying to rebuild them from source that might have been built 6 months ago. What this means at the end of the day is that we end up getting all of the packages that we need to fulfill a point release, and hopefully in the future major releases as well on .zeros on the day that they're ready. We only have to build any packages that may have been updated by listening to the feed there. So that's something that's really exciting too about the future of both 9 and hopefully 8 in the future too.
That's great. Thank you. Skip, I know Tron posted a comment in here. Don't do this at home, or just don't do this in general. And I want to know how many boxes you've actually done this with, or do you have that are running this right now?
You break it, you buy it. Yes. No, I would. Don't do it unless you're willing to put up with the consequences, right? So I do it. I'm a Rocky Linux release engineer. I do this kind of thing all the time, but I'm crazy. So that's comes with the territory.
You just like breaking stuff. That's what you're saying. So now Raymond has a question specifically about SPAC. I'm assuming you know SPAC a little bit. Can you elaborate on when Peridot is a better solution and when SPAC should be preferred?
I'm actually not.
I don't know what that is, so I need to rely on Neil to get here.
So from my understanding, SPAC is more of an HPC packaging tool. So being able to make sure that the right things for your HPC specific software get packaged together, being able to do it for different architectures and actually deliver that kind of like.
Yeah, so
my understanding of it is like Yum for HPC.
I don't think the tools are really related. Really, like I said, Peridot, the scope of it, it's for building RPMs. Ideally, in our case for Rocky Linux, but it could be any RPMs, and also importing RPM package code. So there's really not a whole lot of overlap there. Like I said, in the the HPC community, I guess I'm not really familiar. I'm not super familiar with SPAC or HPC in general, so I can't speak too much to it. If that makes sense.
Yeah, from my very limited understanding of it, they are very different tools for different things. Greg may be yelling at me through the screen somewhere, but I don't know. Scott Lake had a question. Is Podman or Docker CE replaced on Rocky 9?
So Podman would be kind of the default if you were to go and install, but there's certainly nothing stopping you from installing Docker CE as long as you don't have Podman installed. There may be some ways that you can get them to install together, but Podman's actually pretty feature complete now with the Docker CE engine for a container runtime, including I think they have almost full support for like the Docker Compose format as well through Podman Compose. I personally like Podman a lot more than the Docker engine for the actual pod functionality of it and being able to run multiple containers inside a single namespace and connect them together in that way. But there's certainly times where I need the Docker runtime too. So I do have both installed on my current system.
I have noticed that whenever you, we'll ask this question first. Where's Peridot source located, and how do I contribute bugs, docs, and code?
Yeah, we're on GitHub, man. GitHub.com/RockyLinux/Peridot. All right. Did I get it right, Mustafa?
I think it's Rocky-Linux. I think
Rocky Linux. If we can put that up. Put up the right URL if we do it there, but
yeah, they'll correct it. Don't worry.
Yeah,
we'll fix it.
But yeah, when we have issue tracker there, GitHub has excellent tools for that kind of thing. So, file bugs, merge requests, pull requests, whatever you want to call them. Check it out. Yeah,
it's great. Skip, I think we had talked about doing a little bit of a demo, kind of showing the UI interface.
Yeah, showing is better than telling, right? So. I'm going to go ahead and we'll do and by the way, everyone, I'm going to see if I can share my screen here. Share screen. Okay, it gives me some tips. Yep, sorry, I'm not super Okay, hang on a second. Hang on. We're going to do this here. Yes, and we're going to. Bam! Can everybody see that?
Hey, there we go.
Yay!
Okay, cool. So this is public, by the way. Rocky Build, Rocky Linux as a community project. Our build system's public. We don't care. We love people to see it and show it off. So peridot.build.resf.org. Anybody can go here, unauthenticated, of course. And yeah, we're just gonna poke around here. You see already. So we have projects. Mustafa was talking about the projects. Hang on a second. Let me move that out of the way. Yeah, so we have several in here. You see the one that we've been talking about the most here, Rocky Linux 9. But however, we have, you can see there we talk about SIGs, which are our special interest groups, and they're for building all kinds of things. Like for example, I know there's go Raspberry Pi. We make Rocky Linux for Raspberry Pi. This SIG alt arch is where the packages related to that are built, right? And so I'm just going to poke into here. Rocky Linux 9 will definitely have the most packages and builds, so I'm just going to kind of poke around a little bit. And hang on, I see a comment there. It says, please zoom in a little more. Bigger? Bigger's better. Yeah. So just pull it up on your own machine. It's okay. It's cool. But yeah, and you can we'll go to tasks here, for example, and you can see us, as we do things. You can follow along. Yeah, it's great. I mean, you can see we had some trouble building some of our graphical Vulkan tools here. That got sorted out. You can see when it happens, who did it, etc. Right. So here's some lots of imports, and like I said, there's two types of tasks for the most part. There are imports and builds. Right. We import code from upstream. In this case, it's Red Hat Enterprise 9, and we build it. And yeah, you can check it out. Check out all our logs here. You can see, under the hood, we're just using the mock program, if anybody's familiar with that, which is a kind of a wrapper around the good old RPM build. And yeah, you can see everything. Investigate for yourself. I love investigating everything that happens here. Some of these, the logs are way up here. Oh, that's just a destroy pod. But yeah, so we can, and for example, we also mentioned, these are all our packages. We have, we said that the repositories for Rocky 9 are kind of created, ready to go in Peridot, and we weren't lying. You might recognize some of these names in here, and you can actually see what we have. Click on base OS here, and we'll show you there's filters and such that show you, hey, all of these packages. We have an include list, an exclude filter, and then a list of packages, and all of these are what's in base OS and Rocky 9, right? And it's literally, we build for 5 different architectures, right? So it's got everything in here. And yeah, you can, like I said, explore on your own. I love exploring. That's my thing. And we will look. I'm going to show you a different window here real quick.
While you're doing that, just to comment, all of the data that goes into those repositories and how we feed those filter lists and everything else, all in GitOps. So like we were talking about with the patches that we apply, there's full transparency and visibility into what we're doing and how the packages end up where they end up.
So this is another window, and this is me authenticated here, and I just want to show the we have a few extra options here that you won't see if you're just browsing this from the internet. And
Zoom in again, Skip.
Thank you. How about good? All right, and that's by design. And something we're going to look at here is we'll see. This is kind of what we're talking about here when we say we want to import and we want to keep things extra clean and extra automated and traceable, I guess is the word I'm looking for. But so here we're basically, we import from git.centos.org, which is where the Red Hat sources are located, and all of the sources are C9 branches. If you look on there, they all have it's not really CentOS 9, it's RHEL 9. It's just done that way for historical reasons, and we literally bring them in and to our git.rockylinux.org, and we convert them to R9 for Rocky 9, of course. And yeah, it's very like I said, you can check out what we're doing here. If you come here and you see, for example, let's look back at the failed builds here. You see a lot of this happen. You can be nice to us on chat. If you're in our chat, we're probably having a bad day, so just be cool if we're a little short with you, because well, we got packages failing and we got to build them. So and this system is how we're able, something that we're very proud of is, as updates, particularly security updates to all these packages come in, we're able to detect them from the upstream Red Hat sources, import them to our system, and build them usually less than 24 hours, right? So it's very, very automated and very, I don't know, fluid, right, in the way that we're able to tackle this stuff. So, oh, whoa, mirror fight. Okay,
that's awesome.
Okay, I'm gonna. This is from Spaceballs here. Hang on a second. Let me stop sharing. Oh, there we go. Okay, thanks, guys. Yeah, okay, cut me off here.
Hey, Skip, when one of those turns red and it fails, does somebody get notified, or is it just people are watching, pay attention? And
yeah, so usually builds are, and this is something that Mustafa and Neil can definitely chime in more. Usually builds are triggered by people, whether in mass, sometimes we'll do 20 or 50 at a time, or individually, we want to build, we only have like 3 updates we got to do, so we build that. And generally speaking, we just watch it. It's very simple to just, the red or green. We're not colorblind, fortunately, so it's very, X or check. You don't even have to be color. You don't even need colors. But it's quite. It's a little manual right now, but I think Neil and Mustafa can speak to. We're looking at a new enhancement, right? We want to automatically open up bug reports whenever something fails. I think is that the. Yeah, Mustafa, you want to say any more about that?
Yeah, so that was the plugin part that we were talking about, watching queues. We will probably only report, automated imports and builds failing, since, if you trigger a build manually, you probably are watching it. And we also have a cool feature called build batches, so you can, go over the batch and, see what in the batch failed. So you don't have to like scroll through and see, what failed. You should get like that information already. So, and also I just want to mention, we do have like partial support for, even though a distro is RPM based, it doesn't have to be like Red Hat based. So we do kind of support partial support for SUSE builds as well. So that's also cool. You can configure that per setting. So you don't need to like set up a new build system specifically for a specific type of RPM distro. You can just create a new project if you want to manage that locally or in your own Peridot instance.
Very interesting.
Yeah. And some of those things about building packages and not only just the automated side, but submitting them in batches, etc. We'll be building kind of our own sort of sent package, fed package command that will help us as release engineers and community members as part of special interest groups build their packages, check on their packages, and interact with them from the command line instead of clicking around in GUI if they don't prefer to do it that way.
Very good. So guys, we're getting actually close on time. So I'm going to give each one of you the last. What would you like everybody to leave knowing about Peridot? So I'm going to start with Skip. Yeah, great to Skip.
Oh God. Oh no. Yeah, just that it's really cool, and that, just what we use it for behind the scenes in Rocky Linux is too many people don't know anything about what happens behind the scenes, and it's super important. It's really, people ought to understand more about how packages are imported, where they come from, how we're doing that in a secure, automated way so that we get the correct sources for, so that basically, so that your Rocky Linux distro is good, right? So it's exactly as we meant to build it.
Yeah, building on Skip, just the systems that we've put in place and the manners in which we've implemented the features in Peridot and designed it with a purpose in mind. We were kind of, and I say we kind of lightly, Mustafa was very opinionated in how some of these features are built for Peridot, because we wanted them to be done in a way that allowed us to provide traceability and accountability for what's happening in the distribution. Days after Rocky Linux kind of was formed as a project back in December 2020, there was the major SolarWinds hack where they found that there was code running on millions of people's systems around the world that had gotten there from supply chain security. So that's something that has been on all of our minds since almost literally day one, and Peridot and the infrastructure that we built around it is our answer to how do we know when I download Rocky Linux that it's really Rocky Linux and no one has put in something that shouldn't be there.
It's fantastic. Thanks for calling that out, Neil. Mustafa, I'm going to give you the last word on this one.
Since I'm mostly like on the developer side, I would make it easier so people can start developing it. And we're actually working on a lot of improvements, one command cluster, so you can actually test locally. You can test your changes to Peridot locally and PR it back to the RESF and test it, and it should be easier. So we want more people to join us, help us build it out. We want to have more documentation and easier deployments, and just working towards making it easier to manage and install and work on.
That's great. Thank you very much, guys. Thanks for joining me today. I appreciate it. Thanks for giving us a deep dive into kind of what Peridot is. Looking forward to what comes out at the end. Looking forward to getting Rocky 8 in there, Mustafa, at some point. So really appreciate you guys joining. Like and subscribe, and we will see you next week.
Thanks, everyone.
Thank you.
Thanks, folks.